Hey, do you remember about the number system we learned last week?
I don't remember either, but I think Aisha knows.
Let's go meet her then.
Okay, hey Aisha. Bye.
Are you learning number system? Can you please teach me about number system that we learned last week?
Okay, wait ah. Okay, first you must know the number system.
Number system have decimal numbers, binary numbers, octal numbers, and hexadecimal numbers. Next, we move on to relation between binary number system and others. First, binary, decimal, octal, hexadecimal. First, we look to binary and decimal. Convert decimal to binary. Okay, for example, 25 base 10. So first we need to divide by 2. So 25 divided by 2. We get 12 remainder 1. So 12 divided by 2 get 6 remainder 0. So the answer will correct when we get this one and this one. So the answer is that from bottom to top. So the answer is 1 1 0 0 1 2. Okay. Second, binary to decimal. For example, 1 1 1 0 0 1. First step, we need to multiply with weight or position. So 0 1 2 3 4 5. So it will be so after that we need to add all these numbers. So we get 57 less than. So next we look to binary and octal. First, binary into octal. Okay, for example, 0 0 1 0 1 1 1 1 is 2. Okay, this is the step to know the technique to remember the conversion. This table is for hexadecimal, but we can use to octal too. Okay, first step, 0 1 0 1 0 1. Okay, second part, 0 0 1 1. Third, 0 and last we divide to 8 8 0 0 0 0. Okay, so we can use this for octal, but we does not use this number. We just use 3 numbers and back. Okay, 1 1 1. Okay, 1 1 1 is 7. 1 0 1 is 5. 0 0 is 0. So the answer is 57 is 8. Okay, next octal to hexadecimal. Okay, for example, 65 less than. Okay, we use like binary octal conversion. So 5, we look to this table. 5 is 101. So 101. 6 110. 110. So the answer is 110 101. But if the question asks to 8 bits, we just add 00 at them. So the answer is this. So next we move to binary and hexadecimal. First, binary to hexadecimal. Okay, for example, 0 0 1 0 1 1 1 1. So we need to separate this to 4. 1 1 1 1 1. Okay, so we look at the table. 1 1 1 1 is F. 0 0 1 0. 0 0 1 0 is 2. So the answer is 2F. 16. Okay. Okay, next. Hexadecimal to binary. For example, A, B, C, D. Okay, so we just look at the table. So D is 1101, C is 1100, B is 1011, and A is 1010. So the answer is 1010, 1011, 1100, 1101. Okay, before I forget decimal fraction into binary, also the hot expression. For example, 3.70312. Okay, first we need to change first at 3 ni to the binary. So 3 is 11. Okay, so okay, first we need to change 3 into 0 and times 2. Okay, this will get 1.40625. Okay, so we must take 1 to the other part, this, and change 1 into 0 and times to 2, and it will be repeated. So when we get 0.0 times 2, we stop. Okay, so the answer is we need to from top to bottom. So the answer is 011, 012.
But I only know this part.
But I want to know other parts too.
I think I can explain to you the other part.
For example, 8 minus 5. We have to change it into 8 plus negative 5. 6 minus negative 3. Change it into 6 plus 3. Negative 10 plus 2. Negative 10 plus 2. And then in sign and magnitude, we have a few situations. First situation is both are positive. If both are positive, we just have to proceed to the operation. 5 base 10 plus 3 base 10. Change it into binary. 0, 0, 0, 1, 0, 1 base 2 plus 0, 0, 0, 0, 1, 1 base 2. So the answer is 0, 0, 1, 0, 0, 0, 2, which is 8 base 10. If both are positive, we just have to proceed to the operation. But if both number is negative, we have to, as example, negative 3 base 10 minus 4 base 10. Change it like this. So negative 3 plus negative 4. Okay. Change this into binary. So it will become 1, 0, 0, 0, 1, 1 base 2 plus 1, 0, 0, 1, 0, 0 base 2. This one and this one is for the sign that I explained earlier. 1 represent negative. Since this is negative 3 and negative 4, so we have to add 1 at the front. And this is just for sign. But if we proceed to the operation, we have to ignore the sign. Ignore this one. So it becomes 0, 0, 0, 1, 1, 2 plus 0, 0, 1, 0, 0 base 2. The answer is 0, 0, 0, 1, 1 base 2. 1, 1 base 2. And then since negative 3 plus negative 4, the answer is negative 7. Since it is negative, we have to add 1 at the front. 1, 0, 0, 1, 1, 1, 2. So this answer is negative 7 plus 10. Both sign different, we have two cases. First case is negative number is greater than positive number greater than negative number. Second case is negative number greater than positive number. For this case, the example is negative 2 plus positive 4. So we have to set the sign of negative number, so it changes to positive. The example is this will become 1 for the negative sign and 0, 0, 0, 1, 0 base 2 plus 0, 0, 0, 1, 0, 0, 2. This is base 4 into binary 2 into binary form. This is negative 2 into binary form. And then we have to subtract the smaller magnitude from the number with a bigger magnitude. So 0, 0, 0, 1, 0, 0 base 2 minus 0, 0, 0, 0, 1, 0 base 2. So we will get 0, 0, 0, 0, 1, 0 base 2, which is 2 base 10. For the second case, which is negative number is greater than positive number, we have to subtract the positive number from the negative number. The example is positive 3 base 10 plus negative 5 base 10. Change it into binary number 0, 0, 0, 0, 1, 1 base 2 plus 1, 0, 0, 1, 0, 1 base 2. And then 1, 0, 0, 1, 0, 1 base 2 minus 0, 0, 0, 1, 1 base 2. So we will get 1, 0, 0, 0, 1, 0 base 2, which is negative 2 base 10. The next is 1 complement. In 1 complement, we have a situation called overflow. Overflow will occur when in two situations. First is both negative number. Next is both different sign, but it positive number greater than negative number. So for the first case, which is both is negative, for example is negative 3 base 10 minus 4 base 10. We have to change it into addition, so negative 4 base 10. And then the solution is we have to convert negative 3 base 10 and negative 4 base 10 into one complement representation. So positive 3 base 10 is 0, 0, 0, 0, 0. This. And then for negative 3 base 10, we have to change all in this. 0 into 1, 1 to 0. So 1, 1, 1, 1, 1, 1, 0, 0, base 2. The same goes to negative 4 by negative 10. Base 10. So 0, 0, 0, 0, 0, 1, 0, 0. Base 2. Oops, sorry. Before positive and negative. Then change everything. And then we have to perform the addition operation. The addition operation for this negative 3 base 10 plus negative 4 base 10. So then we perform the addition operation for negative 3 base 10 plus negative 4 base 10. So we get 1, 1, 1, 0, 1, 1, 1, 1. 1, this is the overflow. This is the overflow, or this is called EAC. EAC needs to be added to the most right bit. So 1, 1, 1, 1, 0, 1, 1, 1 plus 1. So it becomes 0, 0, 0, 1, 1, 1, 1 base 2, which is negative 7 base 10.
Aja, I really don't understand about Boolean, algebra and logic.
Calm down, Aisha. It's okay. I'm gonna help you.
So, for basic operation of Boolean algebra, we need to know about logic variables and logical operations. In logic variables, there are two possible values, which is true and represented by number 1 and false represented by number 0. Secondly, logical operation, which is AND represented by a dot or represented by a plus symbol and also NOT represented by not symbol. Before we move on further, there are 5 logic gates that you need to know. The first one is the AND gate. AND gates can only have two inputs and one output. The Boolean algebra can be written as y equals to a dot b or y equals to ab. The output of the AND gates depends on the operation of the gate. The second one is OR gate. OR gate have two inputs and one output. The Boolean algebra for OR gate can be written as y equals to a plus b. The output for OR gate depends on the operation of the gate. Third one is the NOT gate. NOT gate can only have one input and one output. The Boolean algebra can be written as q equals to a naught. The output is always the opposite of the input. NOT AND gate. NOT gate can only have two inputs and one output. The Boolean algebra can be written as y equals to a dot b naught or y equals to a b naught. The output depends on the operation of NAND gates. Last one is the NOR gate. NOR gate have two inputs and one output. The Boolean algebra can be written as y equals to a plus b naught. The output is always the opposite of the OR gate. Next, there are 10 basic theorems of Boolean algebra that you have to know. The first one is identity elements. It can be written as 1 dot a equals to a or 0 plus a equals to a. The second one is inverse element, which can be written as a naught dot a equals to 0 or a naught plus a equals to 1. The third one is idempotent elements, which can be written as a plus a equals to a or a naught a equals to a. The fourth one is boundless law, which can be written as a plus 1 equals to 1 or a dot 0 equals to 0. The fifth one is the distributive laws, which can be written as a dot b plus c equals to a dot b plus a dot c or a plus b dot c equals to a plus b dot a plus c. And next one is order exchange laws, which can be written as a dot b equals to b dot a or a plus b equals to b plus a. The next one is absorption law, which can be written as a plus a dot b equals to a or a dot a plus b equals to a. Number 8 is a associative laws, which can be written as a plus b plus c equals to a plus b plus c, or you can write it as a dot b dot c equals to a dot b dot c. Next one is elimination laws, which is a plus a naught dot b equals to a plus b. Second one is a naught a dot a naught plus b equals to a dot b. And the 10th one is De Morgan theorem, a plus b naught equals to a naught dot b naught. And the second one is a dot b naught equals to a naught plus b naught. All the theorems and laws can be proven by substituting the value of 0 or 1 for each variables a, b, and c based on the truth table for each logical operations given. Next, moving on to Boolean function, which is a combination of basic Boolean operation. For example, number 1, f equals to a dot b plus c plus d naught. It can also be written as bracket a and b or c nor d, or a and b or not c or d. And the second example is g equals to a dot b bracket plus c plus d naught. It can also be written as a and b or c nor d, or a and b or not c or d. So how are we going to solve this function? Firstly, we're going to start with the first bracket with a and b, and moving on to c nor d, and then we combine and we'll get the answer. For your information, Boolean algebra is the mathematical foundation of digital circuits, and it specifies the relationship between Boolean variables, which is used to design combinational logic circuits using logic gates. Oh, really? Can you explain further? Yeah. Okay, I'll give you an example operation, which is f equal to a dot b plus c plus d naught. So our first step is separating the equation into two sides, this and this. We should make a bracket on the left side, which is a dot b, to make sure we solve it first before proceed to the right side. So it will become f equal to a dot b in bracket plus c plus d naught. Okay, let's do it. Okay, we use the and symbol, which is multiplying A and B. A and B. Then, and we should use the or symbol to plus C and D. But the equation said C plus D naught, and we should make it NOR symbol by adding a small circle. Lastly, between A dot B and C plus D naught, we should plus by using OR symbol, and we get F for the output. F. Let's proceed to the truth table. We have two input, which is P and Q, and we fill it with the common binary number, which is 0, 0, 0, 1, 1, 0, 1, 1. And then we make the easiest one, which is P, not P. 0 will be 1, 0 will be 1, 1 will be 0, 1 will be 0. And then let's proceed to the next. Not P plus Q, which is not P and plus Q. 0 plus 1 will be 1, 1 plus 1 will be 1, 0 plus 0 will be 0, and 1 plus 0 will be 1. And then P plus not P plus Q in bracket will be 1, 1, 1 and 1. Not P dot Q will be 0, 1, 0, 0. And the last one will be 0, 0, 0, 0. Okay, then we have see the output, all truth and all false. If all the output is all truth value, we call it as tautology. For this. And if all the output is false, we call it as contradiction. For this. Now we are going to learn Karnaugh map. Karnaugh map is a convenient way of representing a Boolean function of all small numbers up to 4 of variables. For the first example, 2 variables, which is we have 2 alphabet, which is A and B. N is 4 variables, so we make it 2 power of 2 equal to 4. This 4 means we have 4 squares in a Karnaugh map. So we make a table with 4 square and A, B. We put the 0 and 1, 0, 1. So we see 0, 0 will be 0, 0, 0, 1, 0, 1 here, 1, 0, 1, 0 here, and 1, 1. So for the alphabet will be A and B, B not B, A not A. So A not and B not will be A not, B not, A not, B, A, B not, A, B. Okay, then we make a 3 variables, which is 2 power of 3 equal to 8. That means we have 8 square of Karnaugh maps. Okay, we make the 8 square with A, B, C. 3 variables means we have 3 alphabet, which is A, B, C. So we put 0, 1 because these have 2 variables, so it will be 0, 0, 0, 1, 1, 1, 1, 0. Okay, why 1, 1 first before 1, 0? Don't ask why, we should put 1, 1 first, then 1, 0. It is the formula. So it will be 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0. This 1, 0, 0, 1, 0, 1, 1, 1, 1, and 1, 1, 0. Okay, next I will explain about equation, which is a standard equation. X equal to A naught B C plus A B naught C plus A B naught C naught. This is 3 variable which contain 3 alphabet A, B, C. Then we look at this. X. A naught means false, so 0. B true, C true, 1, 1. Plus 1. B naught will be 0. And 1. Plus 1, 0, 0. Then we make a table. A, B, C. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So, based on this equation, 0, 1, 1. So, we look at this. 0, 1, 1. So, we put 1 at this. And then 1, 0, 1. 1, 0, 1. So, this is here. And 1, 0, 0. So, 1, 0, 0. Next, for non-standard equation, we have Z equal to B dot C C plus A naught C naught. And then we make it as manual. This part will be A plus A naught in bracket dot B dot C. Why we should put A? But the equation doesn't have A. Every part should contain A, B, C. So that's why we put A in this bracket. And then for the second part, B doesn't have B. So we make B plus B naught dot A naught dot C naught in bracket. And then we look for numeric expansion. As what I said just now, it should contain A, B, and C. For the first part, this part, A, B, C. B, C is true, so we put 1 and 1. But A, we can choose either to put 0 or 1. So it will be 0, 1, 1 or 1, 1, 1. And for the second part, A naught, C naught. A naught means 0, C naught means 0. So B, we put it here and it can be 0 or 1. So it can be 0, 0, 0 plus 0, 1, 0. Then we make a table A, B, C 0, 1 0, 0, 0, 1, 1, 1, 1, 0. So based on this 0, 1, 1, 0, 1, 1. So put 1 here. And then 1, 1, 1, 1, 1, 1. Put it here. And then 0, 0, 0. Put it here. 0, 1, 0. Yeah.
Hey Atira,
Yeah?
can you teach us about the last subtopic in this topic?
Yeah, sure.
Let's go. This is the perfect class.
So why the bells ringing? This is because the alarm has been set up by using logical circuit concept. Okay, this system are using some variables such as time, which is T, doors, D, and windows, W. So there is two conditions, which is 0 for work time, 1 is not work time. 0 is closed, 1 is open. 0 is closed, and 1 is open. Okay, based on this variable, we can use this table. Okay, this table when transformed to binary number, it can be like this. Okay, to know when the bell is ringing or not, we can use this logic gate. Okay, we take one condition from this table. B equal to T, W plus T, D. Okay. T, W, and D. This 0, 0, and 0. Okay. 0 when came to AND gate, it will become 0. 0 and 0 when come to OR gate, it will become 0. So, the output will become 0. When we look at the table, the output is 0. B equal to 0. So, the door will not ringing. For ringing bell, we can take this situation. T equal to 1, W is 1, and D is 1. Okay. T will become 1 at here. When 1 and 1 came to OR gate, it will become 1. Here, we put 1. When 1 and 1 at AND gate, it will produce 1. So, the output is 1. So, the gate will ringing. Okay, next subtopic is to building logical circuit using only NAND or only NOR gates. Most components in computer are built using only either NAND or NOR. To build a circuit that only use NAND or NOR gates, firstly, the expression for the circuit has to be changed into an expression that only has either the NAND or NOR operation. Okay, for NAND gate, for this situation, it will become like this. for the NAND gate. Well, for NOR gate, with same situation, which is T times W plus T for NOR gate, it will become like this.